and doing the correct work. Obviously, there are multiple methods to solve every problem. I won't be able to go through every single one of them, but hopefully this is a good enough explanation. Definitely talk to your teacher if you would like another method or if you need further explanation. So let's look at number 1. So number 1, we can tell that we need a factor, and we are trying to think of our different patterns. So I'm going to notice that there is a subtraction sign, and I'm going to notice that our exponents are even. So this tells me that this might be difference of squares. So I'm noticing those things. So let's try it. Let's take the square root of the first term. Remember that this means that we need to take the exponent and divide by 2. So the square root of 9 is 3, and then that would be x squared. Then I'm going to ignore the subtraction sign because that's part of the pattern, and I'm going to take the square root of the second term, which is y squared. That's just going to be a y. So it looks like I had perfect squares. I have a subtraction sign. So let's go ahead and get into it. So we're going to need 2 parentheses. These are small and small. So you need a plus and a minus sign. It technically doesn't matter which one is which. Then you're going to be doing the square root of the first term in the beginning. So 3x squared and 3x squared. And then you're going to be doing the square root from the second term in the second spot. And then you're done. If you wanted to check your work, you could have done box method with these, and you would get back to standard form. Because remember that this is factored form, and then your original was standard form. Alrighty. Let's look at number 2. So number 2, we need to find the common factors. So find the common factors in between these 2 problems. Okay, well, let's get into it. So if we need common factors, we know we need to factor it, and then we need to see literally what's in common. So I'm going to pretty much treat this like 2 separate problems. So I'm going to do 3x cubed minus 5x squared minus 12x. So first thing we always check for is a GCF. So I notice that I have an x in common because all these terms have an x. And that's really it. That's all I have in common is a x. So then I'm going to actually divide. So I get 3x squared minus 5x minus 12. Now that I have a quadratic, now I can do my whole a, b, c, and x method. So we know our a is 3. Our b is negative 5. Our c is negative 12. So I'm going to do our x. So that's going to be negative 36 and negative 5. The side numbers should be negative 9 and 4. Remember that you're going to set up your parentheses. So x minus 9 and x plus 4. Don't forget about your GCF. So x will go in front. But then you got to remember to divide by your a. So in this case, our a is 3, so we're going to divide by 3. So that means we end up getting x times x minus 3. This one did not simplify, so 3x plus 4. So these are the factors. There's 3 factors for this first problem. So then, let's go ahead and now do the second one. So we've got negative 2x squared minus 2x plus 24. Now for this, I can see that there's a negative sign in front, so I know I need to handle that. And I should see that all of these numbers can be divided by 2. So I'm going to go ahead and do my GCF as a negative 2. Okay, so now I'm going to actually do the division. So x squared plus x minus 12. Again, we can't forget about our GCF, but we have a quadratic. So, and I've got my 3 terms. So let's do our A, our B, and our C. All right, set up our X method. So negative 12 and 1. So that means our side numbers would be 4 and negative 3. Again, I'm going to set up my parentheses. So GCF in the front, negative 2, and then x plus 4, and x minus 3. Again, we're going to divide by a. So our a is 1, but this time if I divide by 1, nothing's going to change. So I still have negative 2 times x plus 4 times x minus 3. So these are the factors of that polynomial. So now we want to know what is in common. What do they both have? So notice how they both have an x minus 3. All the other factors are different between them, but they both have an x minus 3. So that is what's in common. All right, let's go ahead and look at problem number 3 here. So again, we're looking at this, we're noticing some details. Now this one also has a minus sign here. Okay, so maybe it's difference of squares. I could see that 64 is a perfect square, but what we've got to pay major attention to is this exponent. That exponent is not divisible by 2, which means that this cannot be difference of squares. What it is, though, it is divisible by 3. If it's divisible by 3, then this might be a perfect cube. So make sure you're paying attention there. I saw lots of people trying to do difference of squares, but let's take a look. So if I do the cubic root of x cubed, remember that means we're taking our exponent and we are dividing by 3. So that means we would have x to the first power. So then we would be taking, again, leave the negative sign because that's part of the pattern, the cubic root of 64. And we know that that's going to be 4 if we do it in our calculator. So that means this is definitely a perfect cube. So then we need to set up our parentheses. We know that we're going to have a small and a big. If we're doing our SOAP, we know same. So if this was originally negative, there's going to be a negative here. Opposite, always positive. So SOAP. All right. We now need the first term, the cubic root of the first term, x, and the cubic root of the second term, 4. Remember, in the first spot and the last spot, we're going to be squaring. So we know that we're going to have x squared and 4 squared. In the middle, we're going to multiply our 2 terms, x times 4. Obviously, we need to get this cleaned up just a little bit. So our answer here, we're going to have x minus 4. X squared is literally just x squared, plus x times 4 is 4x, plus 4 squared is 16. And we're done. All right, let's look at problem number 4. Nope, it won't let me move it down all the way. That's okay. All right, we need to find the sum of the solutions. Sum of the solutions. So notice we have 1, 2, 3, 4 terms. So that makes me feel like we need to do grouping. And let me back it up too. This problem said nothing about factoring, but remember that we get solutions from factors. And right now we are in standard form. So I know that I need to switch this to factored form in order to even get my solutions. So, grouping first though, start with your GCF. I don't see a GCF. There's no X in common. There's no 2 or 3 or anything I can divide by. So that means we're going to divorce. Remember, we're going to take the first 2 and create them as a group. Some space. And then the second group. Alright, now we need the GCF of each group. So for this first group, I can divide by an x squared. And for the second group, I can divide by, make sure you grab that negative sign, a negative 9. Okay, let's actually do the division. So we're going to have x minus 4 and x, and be careful here, that's going to be minus 4. So notice that your 2 leftovers here, they match. So that's a good thing. So now let's set up our factors. So we're going to have our GCFs come together. And then our leftovers. Okay, everything looks good except for I should notice something. I should notice that right here, this x squared minus 9, see how this factor has a square, is a quadratic? That means we need to check if it can factor again, if it can factor further. So let's literally then take, okay, x squared minus 9. Well, let's look at it. We've got a square here. It's a binomial, and we have a negative sign. So I think this is difference of squares. So let's check. What's the square root of x squared? It's x. What's the square root of 9? It is 3. So that means we can break down this one factor into 2 factors. We can now have x plus 3 and x minus 3. And then don't forget your original factor was an x minus 4. So you now have 1, 2, 3 factors. And now you can get your solutions. Remember that you're going to set your factors equal to 0. And then from there, you are going to solve for x. If you know the pattern, you know it ends up being an opposite sign. So x is equal to 4, x is equal to negative 3, and x is equal to positive 3. So now if I need the sum of these, we know that 4 plus a negative 3 plus 3 is just going to be, those would be 0, so it's just going to be 4. So that's your answer. Some of you tried to do, like set up an equation where you set x squared minus 9 equal to 0, and then you like added 9 and undid the square. You can do it that way, but you have to remember that if you undo a square, technically you have to have both a plus and a minus. So just be careful with that. All right. Problem number 5. So we need to set up our standard form. We can tell it's standard form because of the answer choices. And we've got a leading coefficient. And we've got some zeros, and notice we have a multiplicity. So we have x is equal to 2/3, and we have that twice. And then we also, we only have that Oh yeah, we do have that twice. So good. Okay, have that twice. And then we have x is equal to negative 4. So again, we want to change these solutions back into factors, which means we want to make the right side equal to 0. That's our goal. We don't want any fractions, so we're going to undo our fraction by taking the divided by 3 and multiplying by 3. Be careful, 3 times x is 3x, and that's equal to now just a 2 left over. We're then going to subtract 2. So remember, we wanted the right side equal to 0, and then the left side is 3x minus 2, so that means that's a factor. We don't need to do it again for this one, so we're just going to write 3x minus 2. And this one, all we would need to do is add 4 on both sides. So x plus 4 is equal to 0. So now we have another factor. So let's go ahead and write our factored form. I think some of us need to stop and write the factored form before we start multiplying everything together, just to make sure we've got all of the pieces before we start multiplying. Okay, so notice your leading coefficient in the front, and then I've got my 3 sets of parentheses, and we can go ahead and start to multiply these together. I'm going to first multiply my 3x minus 2 times 3x minus 2 first. So I'm going to go ahead and do that down here. Okay, so that means that I still have technically a negative 1. I have an x plus 4 to multiply. And then from here, I would have 9x squared minus 12x plus 4. I'm going to go ahead and just distribute this negative to make my life a little bit easier. So I'm going to have x minus 4, and then 9x squared minus 12x plus 4. So now I need to set up our box method. And obviously we need to get that filled in. This is where you got to be careful, making sure your signs and your exponents and everything stays organized. Okay. From there, we're going to see if we can combine any like terms. And the answer is yes, we can, because I can combine these x squares together and these x's together. So that means we're going to end up, I'm going to write it up here, we're going to end up with a negative 9x cubed minus 24x squared plus 44x minus 16, which was answer choice A. A lot of us forgot to multiply the leading coefficient, and so then that's how we might have gotten like C for the answer, is if you forgot the LC. All right, let's look at number 6. So, number 6, we need to find the closest zeros. And remember that zeros is another word for solutions. And we need to find the distance. Now, I know for me, I looked at this function and I noticed 1, 2, 3, 4 terms. So I know for me, I started to do grouping. Again, there was no GCF in the beginning, so I had just started to do grouping. We would have been able to factor out a x squared and factor out a -1. We would have actually done the division. I got 4x minus 5, and I got a 23x minus 6. But notice, they don't match. So that means that this is prime, and we need to use Desmos because we need to graph this. Now, I won't be able to pull up Desmos right now in this video, but hopefully you know how to type this into Desmos. You know that you need to sketch the graph. The graph looked something like this. And you know that not only do you need to sketch it, but you also need to label the parts that you're using to solve. So because we're doing solutions, we're looking for x-intercepts. So you had one right here at -2. You had one right here at 0.25. And you had another one right here at 3. So we want the distance to the ones that are the closest to each other. So I know for me, I kind of figured out the distance between like both of them. So if I did from -2 to 0, that would have been 2. And then this would have been 0.25. So that would have been a total distance of 2.25. I know the closest is definitely not going to be between -2 and 3. But I'm going to then also figure out the distance between 0.25 and 3. So that would have actually been 2.75. So the closest one was between the -2 to 0.25. And again, we had a 0 in between here. So that's why we had to do the 2 and then 0.25. So that's a total there, and that was our final answer. All right, let's do 7. Now 7, if we're thinking smarter and not harder, we should notice all of these little radical signs. If you see radicals, you know that your answer is going to be in decimals. And if it's a bunch of decimals, then we already know that our function is going to be prime and that we should then use Desmos. So kind of just, thinking smarter, not harder. If you had started to factor this, you would have been factoring by grouping. But again, just kind of like in the previous problem, it would have ended up being prime and you would have ended up using Desmos. Now, it gave us one of the zeros, aka solutions, but we need to figure out the other ones. So again, you would have gone into Desmos. I think most of us did a good job using Desmos. I think the issue was that we rounded way too much, which caused our answers to be off. So we had this graph. It kind of looked like this. Now, Desmos will give you decimal answers. Again, you don't want to round your decimals too much. You want to be as accurate as possible. -1. And this was at like 1.236. And this other one was at -3.236. So, remember that these little plus or minus signs mean that you're going to be doing like 2 versions. So for example, for answer choice B, if I had split this would have been like -1 plus radical 2 and -1 minus radical 2. So what we need to do is we need to convert our answer choices into decimals. So you're going to be doing that on a calculator. So once you converted all of these, D was the one that had negative 3.24, and it was a 1.24. So D was closest once you converted the decimals. Okay? I think what a lot of people did is they rounded, like negative 3.236. They just rounded it to negative 3, and they rounded the 1.236 to something else, because I saw a lot of people put answer choice A. But again, I think it was because there was a rounding issue. You want to be as specific as possible and as accurate as possible. So just make sure you're converting your answer choices into decimals, and make sure not to round too much. All right, last problem, number 8. So this problem is asking us to find all the items that have a factor of x minus 3. So with this problem, we're trying to make sure that you know the difference between a factor and a solution. So remember that if this is your factor, this x minus 3, then the solution, or the x-intercept, would be x is equal to positive 3. So these two things mean the same thing. So we just need to figure out which of these have that as a factor. So notice for the graph, this graph has x is equal to negative 3. So that meant the factor for this would have been x plus 3. So that doesn't work. I'm going to now go to C, because that one's also easy. Normally CLC is already in factored form. Like this would have been your GCF, and this is also a factor. So notice that this factor is also a plus sign. We need it to be a minus sign. So C cannot be it. Okay, I'm going to go to D. I'm going to go to D next because that's the easiest to factor. I can see that this is the difference of two perfect squares. So I know square root of x squared is x. Square root of 9 is 3. So I'm going to have x plus 3 and x minus 3. Oh, look. This one has an x minus 3. So I know that D has to be one of my answers. It says select all of the items. That means we could have multiple answers. So now let's check E. So E has 1, 2, 3, 4 terms. There's no GCF. So I know I would do group them. So like x cubed plus 3x squared. Give it some space. Negative x minus 3. I would check for a GCF. So x squared. This one, there's a negative in front. So we know negative 1, negative 1. Okay, so then x plus 3, x plus 3. If I bring my GCFs together, it's going to be x squared minus 3. And notice my leftovers are x squared minus 1. And notice that our leftovers are x plus 3. So again, this, we need an x minus 3. This is the plus 3, so that's not going to work. And then for the last one, I'm going to go ahead and do X method. That's going to be A is 2, B is negative 7, and C is 3. So that's going to be 6 and negative 7. So that means our side numbers are going to be negative 6 and negative 1. So I'm going to have x minus 6 and x minus 1. Again, I need to make sure I divide by A. So that means our factors are going to be x minus 3 and 2x minus 1. Look, there's that factor, x minus 3. So that means B is also going to be an answer. Okay? Well, good luck with your error analysis, and good luck retesting.